On August 15, 1977, the tranquility of the night was interrupted at the Ohio State University Observatory. For 72 seconds, a radio signal coming directly from the Sagittarius constellation was captured by the big ear antennas. Contrary to typical movie scenes, where there's always someone present for the first contact, there was no one around at that moment. It was 10:16 p.m. and the telescope's computer room, empty, was printing out hours of nighttime sky observations. Fortunately, days later, Jerry Eman, the astronomer in charge of reviewing the data, noticed something peculiar in one of the printouts, marked by the sequence 6EQUJ5. In a mix of surprise and excitement, he circled the sequence and wrote "Wow" next to it, immortalizing his reaction to what we now know as the wow signal, a mystery that persists to this day. This signal, which may be our best indication of extraterrestrial civilization so far, doesn't hide a coded message, as some might think. In fact, the sequence 6EQUJ5 is a representation of the signal's intensity compared to the background noise, where each number or letter indicates how much stronger the signal was. An intensity of 1 means a signal slightly above the background noise, increasing up to 9, and continuing with letters up to U, which represents an intensity up to 31 times greater than the background noise. The signal's 72-second duration and its maximum intensity, about 31 times greater than the background noise, suggest it wasn't a random detection. This is more related to the configuration of the Big Ear telescope itself, which, with its 2 detectors, could observe 2 regions of space simultaneously. Unlike other radio telescopes, the Big Ear couldn't fully adjust its position. It only changed its angle relative to the horizon, with Earth's rotation moving the telescope across the sky. So, what makes the WOW signal so special if telescopes are constantly detecting signals? Its intensity is crucial for us to assert that it originated from a real phenomenon, not just a glitch. However, what truly sets it apart is its frequency. To grasp its significance, let's go back to 1959, when physicists Philip Morrison and Giuseppe Cacconi speculated on how intelligent civilizations would attempt to communicate. They concluded that the most logical means would be through electromagnetic waves, given the vastness of the electromagnetic spectrum. Interestingly, everything we see in our daily lives corresponds to only 0.0035% of the total spectrum. Different frequencies interact with matter in various ways in the universe, making the choice of frequency a crucial consideration in the search for extraterrestrial communications. Cosmic rays with extremely high energy can be completely absorbed by the atmospheres of planets. And not only that, they would also require an immense amount of energy being used at the source of the signal. But what if I told you about an almost perfect frequency? It sits right in the sweet spot of the spectrum to not interact much with the matter in the universe, allowing the signals to travel for thousands of light years. And at the same time, this frequency should be known by any minimally technological civilization. The frequency in question is about 1420.4 MHz, also known as the hydrogen line or the 21-centimeter line. The reason we believe this would be the most obvious frequency for communication between intelligent civilizations is that it's produced by neutral hydrogen atoms, and hydrogen is the most abundant element in the universe. Theoretically, any civilization even minimally technologically advanced should also know this frequency. And it's super easy to observe throughout the universe since it's not blocked by dust clouds between the stars. And what was the frequency of the WOW signal? 1420.4556 MHz. You're probably wondering if I misspoke. But in 1998, Jerry Eman himself, who discovered the signal, recalculated the frequency value taking into account an error in the construction of the telescope. And 1420.4556 MHz is incredibly close to the hydrogen line, which is around 1420.4 MHz. This slight difference in the decimal places can be explained by the blue shift, a relativistic phenomenon that causes light to increase in frequency when the source is moving towards us. In the case of the signal, the source should have been moving towards us at about 10 kilometers per second. Another factor that helps solidify how unique the WOW signal is so far is that its frequency is protected here on Earth, precisely because it is so important for radio astronomy. We avoid and regulate any human sources to prevent them from polluting the 1420 MHz band, which makes it even less likely that this signal originated here on Earth. Another curious thing about the signal was its duration, 72 seconds. As I mentioned earlier, the Big Ear remained stationary in one part of the sky, while the Earth's own movement rotating beneath it scanned other regions. If you look at the intensity graph, we can precisely track this movement of the Earth as the WOW signal enters the detection zone of the radio telescope. It starts with low intensity as soon as it enters the area that the telescope detects, reaches a peak 36 seconds later when it reaches the middle of the area, and then decreases in intensity again until it disappears 36 seconds later. In other words, we can't determine the actual duration of the signal because we only captured it for 72 seconds. It may have lasted longer than that, we just don't know how long. And unfortunately, due to the design of the Big Ear itself, we can't know which of the two ears of the radio telescope detected the signal, but we can estimate where it came from. Next time you look up at the night sky, try to find the center of our galaxy. Right beside it, you'll find the constellation of Sagittarius, which is the region of the sky where the WOW signal came from. We know which regions of the sky the two detectors were pointing at when the WOW signal was detected. But we can't say which of the two it was emitted from, so we'll need to focus our search on two slices of our galaxy simultaneously. If we're assuming that the WOW signal was sent by an intelligent civilization trying to communicate, it makes sense to look for stars that resemble the Sun the most. Well, we only know of one example of life in the universe, us. The part about being intelligent is debatable, and we orbit a star with very specific size and temperature characteristics. Combining the two areas that the Big Ear was pointed at the time of detection with our most updated star catalogs of the Milky Way, several stars similar to the Sun appear. 66 of them, to be exact. But many of these stars don't have enough data. They may have temperatures similar to the Sun's, but we don't know the size or vice versa. Of the stars for which we have enough data, only one matches perfectly with the characteristics of our Sun. You're looking at it right now. This star has an unimportant name, 2-mass 192819882-2640123. Its temperature is extremely close to that of our Sun, 5772 Kelvin. It's 99% the size of the Sun and has practically the same luminosity. And it's located 1,801 light-years away from us. But whenever we search for something that perfectly matches our data, we have to remember what data we're looking for in the first place. In this case, we're only looking for stars extremely similar to the Sun, and this star was the best candidate. But don't forget that there are at least 66 stars in total that fall within the parameters we also consider acceptable, And we also can't forget that the table from which the star data came only contains the data of stars large enough for us to see. This number of possible stars could increase as we obtain better data. I made it clear during this video that the WOW signal is still our best candidate for extraterrestrial communication. Jerry Eman himself, the astronomer responsible for discovering the signal, agrees with this statement, and he's just one in a list of incredible names in science still seeking an answer to the origin of the signal. And as always in science, we need a dose of skepticism. As Sagan would say, extraordinary claims like the first alien communication require extraordinary evidence to be proven. There have been no shortage of attempts to explain the WOW signal by rejecting the hypothesis that it comes from an intelligent civilization. The most famous one came in 2017, suggesting that the origin of the WOW signal was from the hydrogen clouds accompanying comets 266/P Christensen and P/2008 Y2 Gibbs. Beautiful names, right? At the time of the signal, we either didn't know about the existence of these two comets. But now we do, and we even know that they were in the region of the sky where the signal was detected. The neutral hydrogen from the comet's tails emits waves at the frequency of the hydrogen line, but this emission isn't strong enough to explain the intensity of the WOW signal. Secondly, the astronomers working at the Big Ear at the time reviewed the data and found that even though the comets were in the same region of the sky, they weren't within the regions where the detection was made in 1977. And thirdly, remember when I mentioned that the WOW signal was only detected in one of the detectors and not the other? The comet hypothesis doesn't explain this. If the comets were truly responsible for the signal, they should have been detected in both regions when they passed over them. Another attempt to explain the signal was some kind of emission from Earth being reflected by satellites or space debris in orbit. Initially, Jerry Eman himself agreed with this idea, but articles were published showing the necessary conditions for this to occur. First, as I mentioned earlier, 1420.4 MHz is part of the protected spectrum. No one on Earth is permitted to transmit in this spectrum except for astronomy-related projects. Second, the satellite would need to be in the exact place, at the exact time, with the exact inclination to reflect the signal. And all these separate conditions have such a low probability that it's more likely the signal came from outside Earth than being reflected by a piece of metal in orbit. But perhaps the evidence that contributes the most to our inability to confirm that this signal was indeed sent by another civilization is actually its absence. We've never captured the WOW signal again. More than 100 attempts to capture the signal again have been made, all looking at either the entire sky or specific stars. We've scoured the sector of the sky from which the WOW signal emanated, and we've found nothing but absolute silence. But even that could have a reasonable explanation. On November 16, 1974, 3 years before the WOW signal was received, we sent out the first deliberate message to any intelligent civilization that might intercept it. The Arecibo message, as it became known, was aimed at the Messier 13 cluster, which is 25,000 light-years away. The message consisted of 1,679 bits modulated through frequency, and it carried information about humanity, the structure of DNA, and the numbers 1 through 10. It was created by none other than Frank Drake, the physicist responsible for the famous Drake equation, with the help of Carl Sagan. It was the first message containing basic information about humanity that we sent into space. The entire message was transmitted in less than 3 minutes, or 180 seconds. But the reason I brought up the Arecibo message in this video wasn't to suggest that the WOW signal was a response to it. That would simply be an error. The reason is precisely to analyze what we did with the message. It was sent only once, on November 16, 1974. The entire message lasts less than 3 minutes, which isn't much different from the duration of the WOW signal, which, as we discussed earlier, we only detected for 72 seconds because that was the window during which the telescope's detector was pointed at the source of the signal. It likely lasted longer than that, but unlike our Arecibo message, we didn't detect any frequency modulation in the WOW signal, which in theory would be the way to carry information. More than 45 years have passed since we detected the WOW signal, and we've never managed to capture that signal again. Similarly, more than 45 years have passed since we sent the Arecibo message, and we've never sent it again. In our attempt to understand why we've never detected the WOW signal again, we often wonder why a potential intelligent civilization wouldn't have sent the signal again. But we also haven't sent our signal again. We've adopted silence, and that's how we've been ever since. If an intelligent civilization were to come across the Arecibo message someday, they would probably also wonder why they only received the signal once. And worse, they would probably have done the same thing we did, trying to scan the sky region from which the signal came and attempting to find a similar star, just as we did. But since we've stopped emitting radio waves with modulated messages, they haven't been able to find us either. Again, this part of the video is speculation based on the behavior of the only intelligent civilization we know, our own. And it doesn't make much sense to expect that other civilizations, if they exist, would repeat the signals sent into space when we haven't done so either. The truth about the WOW signal is that it's extremely interesting precisely because it's the best evidence we have so far of extraterrestrial communication. This isn't enough to say definitively that the signal came from an intelligent civilization intending to communicate to the rest of the galaxy that it exists, but in a universe that initially seems extremely empty and hostile to life, the signal is the best we have. Even if its origin is something we still can't understand, the simple fact that it existed and we have so much evidence that it might be the first time we've detected something from another civilization is reason enough not to stop looking up and listening carefully for any sign of life beyond Earth. Who knows, the next time we receive a similar signal, we might be better prepared. Who knows, we might finally be able to pinpoint exactly where it came from. Who knows, we might finally be able to answer once and for all whether we're truly alone in the universe, or if we live in a universe full of life that we still haven't been able to detect or make contact with. We live in the golden age of astronomy, in the golden age of discoveries that shake any notion of meaning we give to our own existence. We can't stop listening and searching. The curiosity of our species is the best tool we have. And the WOW signal is the best evidence that we're not alone to this day.